Good morning, students. Good morning to all of you. Today we are going to discuss a new topic, that is magnetic field due to finite state current carrying wire. We have to find out the magnetic field, the intensity of the magnetic field or the magnitude of the magnetic field around the straight finite length of current carrying wire. Suppose this one a wire having a current of I, and the wire length is finite, and we have to find out the magnetic field at a distance of A from this wire at a point P. Okay, there is a wire, and we know that around the wire there is a magnetic field, and we have to find the magnitude of the magnetic field at a point P from the distance A from the wire. Then we will use the Biot-Savart law to find out the magnetic field here. What is the Biot-Savart law? Let us see here. Suppose this one a wire, and inside the wire there is a current I. Then we cut a length dl, the element we have to find out, due to this elemental current there is a current inside the wire I, and we have to find out the magnetic field due to this dl length at a point P at a distance r, which is making an angle of theta. The magnitude of the magnetic field at a point P becomes dB, and we know that the value of dB is mu naught upon 4 pi I dl sin theta upon r square. This one Biot-Savart law. Okay, this one Biot-Savart law. We already discussed about it. So we will use this the magnitude of dB to find out the magnitude of magnetic field at point P due to this finite length of current carrying wire. So we take a length dl. We take a length dl from this distance L. We take a dl length of element, and due to this dl length we will find the magnitude of magnetic field. We will find the magnitude of magnetic field, that is dB, and we will integrate that magnetic field. Okay, so first we produce a dotted line which touches the one end of the wire from this point P, and we again produce a dotted line which will touch this wire at the another end, and we know that this angle, we consider this one phi 1, okay, and this angle we consider, that is phi 2, okay, phi 2, and again we consider that this angle is theta, the theta. Then we know that this one the 90 degree here, the distance A is perpendicular on that wire, and this one theta and this one 90, then this will becomes how much? 90 minus theta. Okay, then we have to find out the magnetic field dB due to this elemental current. The dl is the current, the direction of dl is toward the direction of electric current. Okay, so we have to find out the magnitude of dB due to this dl. We know that from Biot-Savart law, the dB becomes how much? The dB becomes mu naught upon 4 pi I dl sin, okay, sin theta becomes how much? The theta is this one. Theta is sin theta, means the angle between this r. Okay, we consider this one r. Oh, okay, we consider this one r. The angle between the r and the dl vector. Okay, so we can write here 90 minus theta, and upon this distance is r, so we write here r square, and after it we know that this will becomes how much? Mu naught upon 4 pi I dl. This will becomes how much? Cos theta, and divided by r square. This one dB. And after it we will integrate this equation to find the value of B throughout the whole due to this whole wire. Okay, and our integration is from phi 1, our integration from phi 2 to phi 1. Okay. So we write here minus phi 2. Why we write minus? Because this one in anti-clockwise and this one in clockwise. So both angle are opposite to each other. So we consider first one is negative and the second one, that is this one phi 1 becomes positive. If you put plus phi 1, then we will take the minus phi 2. Okay. We know that from here after integrating we will get b. This one mu naught and 4 pi is a constant, it will come out, and the current I is always constant, so it will also come out. And there is two variable, that the theta is variable. As you increase the phi 2, the theta is also increasing. As you increase phi 1, the theta is also increasing. So theta is variable, and there r is also variable. This one r. So our r is also variable. As you increase the theta, the r is also variable. So there is two variable. So we have to change in only one variable. That is, you can write here dl cos theta divided by r square. If you take this triangle, then we can write here cos theta. Okay, we can write here cos theta equal to this one b, that is a upon this one h r. So from here we can write r equal to a upon cos theta. From here we can write r equal to a upon cos theta. And again in this triangle, we know that this one L, okay, and this one A, okay, we will take the tan theta, okay, we will take the tan theta. This will give P upon B, okay, P upon B means L upon A, and from here L equal to A tan theta, and as you differentiate we will get dl equal to a sec square theta d theta. We will replace this dl from here and we will replace the r from here, so that we can find only one variable, that is theta. Okay, then from here b equal to mu naught upon 4 pi I, and in place of dl we will put a sec square theta d theta in place of dl, and this one cos theta, okay, divided by, in place of r we place a divided by cos theta. This one is square, so we take a square here and a square here also. And as you solve this equation, we get b equal to mu naught upon 4 pi I, and this one a sec square theta into d theta, okay, into cos theta again, and from here we can write cos square theta divided by a, okay, sorry, a square, cos square theta, this one go outside, cos square theta divided by a square. The sec square theta, cos square theta will be cancelled out, and from here a also we cancel out, and from here we get mu naught upon 4 pi I, and there is only one variable, that is from a also we come out, the a is also a constant. This a is the distance between the wire and point P is constant, so it will also come out, and there is a one variable, that is cos theta d theta, okay, and we have to integrate this equation from minus phi 2 to phi 1, minus phi 2 to phi 1, okay, minus phi 2 to phi 1, minus phi 2 to phi 1, okay, and as we integrate you get how much, mu naught upon 4 pi I upon a, and we know that the integration of cos theta is sin theta, okay, from minus phi 2 to plus phi 1. As you put the value, you get mu naught upon 4 pi I upon a and this will gives sine phi 1 minus of sine minus phi 2, okay, minus of sine phi 2. We know that as you solve this equation, you get how much I upon a, this one gets sine phi 1, and this minus will come out and becomes plus sine phi 2, and this one gives the value of magnetic field or the magnitude of magnetic field at a point P from a finite length of wire if the wire having a current I. This value gives the amount of or the magnitude of magnetic field around the finite length of current carrying wire. Okay, I think you are able to follow me. Thank you very much.